Okay, this video, there is too much to show in the time that would be reasonable, so I'm going to have to race through it and show you only a little bit of what this program can do. I'm opening the program from the development environment. It's a program, it's a robot, essentially. Using artificial intelligence, it will check your drawings. It will check layout drawings, part drawings. It's set now for fabrication drawings. So I've imported the set of drawings, which are 11 by 17 fabrication drawings. And let's show you what we can do. It can check for welds, poles, dimensions, bevels, arrangements, section views, quality control data, revisions, all sorts of things. And you'll see later that since it runs an artificial intelligence that it can check more than you could possibly imagine. But those were the default settings that I set it up with. And then we'll do a check here. I'm going to do an optical check. Since we have very little time, I'm going to have a check everything. 38 drawings. So it's just, you can see how fast it checks. And as it finds mistakes, it's marking them in this panel on the left. So it's looking for things that are missing, things that are wrong. And it's just getting started. This coding that we're doing on this is just getting started. There's a lot of training that's happening. This is not a finished project by any means, but it shows you. So I'll check on an alphanumeric scan. Okay, I'm going to sort them. So okay, off to the left, there is a list created, and here's the mistakes it's found. Okay, it's found a missing weld on this stiffener. Should be a 6 millimeter weld on either side. It's not there. Good catch. Okay, on this dimension here, this program runs on artificial intelligence, and it's thinking that it needs a dimension here. It's not provided anywhere else. No. But I wouldn't have put a dimension there myself because you never know, this piece here might not have been cut exactly right. So I like it with the dimension called out on the one end, but it's not trained that well yet. It's a lot of training is going into this, so we'll check this. You see what you think of that yourself. So here's a hole. So it's determined that these holes do not have a dimension call out. But this is where it gets interesting in that there's a call out here that all holes are 21 millimeters. However, it's called out 14.2 millimeters. So anyways, there is a call out, a hole size call out here on this end. And at this stage, there isn't enough training. The program isn't smart enough to be able to say that these holes here are 21 millimeters. Now, the fabricator, shop worker, would have to use this text here without this comment and say, well, these holes are 21 millimeters because of this note. But this checking program doesn't know that. So it's marked it as needing a hole. In the future, when the program gets smaller, it would be able to scan the document, take a look at the size of these holes and the call out, and it might be smart enough to realize that these holes here are the same size and not include this comment. But at this time, it's all it can see is that these holes don't have a dimension call out. And I would like to see a dimension call out here anyway. So essentially, it's the same thing here. There's a comment here, and the program is thinking that there should be a dimension here. I think it should too, but that's up to you. You think what you think of that. Okay, here's a clear catch in that it's gone through the drawings and determined that this drawing needs to be arranged, displayed better on the page. Oh, what do you think of this? The program has found that it thinks it needs a dimension from the top to the bottom. Um, well, it's not there. It's not shown anywhere else. It's up to you. It's a good catch here in that it's determined that there's a bevel here and that there's no call out on the bevel. So that's a good catch. In this case, it's saying that there should be a view. There's no end view, so I think that's a good catch. Yeah, this is interesting. The program, which is still being developed and it's still learning, it's called an range in this instance, and it really should have maybe been a view with a red dot, but still learning. It's accurately caught that there's no weld detail, no typical or anything, so it's determining that we need a 6 millimeter weld on either side of this plate. So that was a good catch. Smart. Yeah. In this case, just so you know, I know how this works. The program has scanned the bill of materials and it's looking for that part in the drawing and it's found it. There's one here. So maybe we didn't need a part call out on this part, but it isn't called out anywhere else. And so the program is saying we should have a part here. I think it should have, but maybe the program will get smarter. Oh, that's a no-brainer there. No revision. And this is pretty easy too. So there's a spelling error. So we're already at 6 minutes and I've only showed you a portion of what it can do. It can do layout drawings, but I mentioned that before. So let's try a button here that's specific AI. Now it's going to do specific AI tasks. The other run button has disappeared and I'm going to check this and I'm going to have it do a whole count, so it's going to do a whole count, go through all the drawings and count the holes. So run here. So in this output text here at the bottom, it has determined that there's 345 holes in the drawings. That's just an example. What I'm trying to show is that it can go through the drawings and glean so much information. I'm going to be having it so that all kinds of applications where you can click from a drawing to a BIM model, all sorts of things. Just all sorts of things that this can do, but you're getting the idea. Here's, let's have it go through the drawings and I'll see. It can go through that assembled drawings. You might be thinking, well, how much paint is it going to take? The program is currently saying it's going to take 32 liters of paint to paint those assemblies. I kind of think it's allowing for a perfect application and no overspray. Yeah, so it's pretty light. I would have thought you'd need 2 pails, 40 liters. So let's try something else. Okay, here let's ask the program. We got an input box here. Let's ask the program to do some checking. I'll just paste this in, okay, and then I'll run the program. Okay, and it's saying that, let's see here, it's got, it says that in that set of drawings, this is kind of report, and it can do material lists and everything, anything you want to glean from this. You can't ask it who's going to win the election, but you can ask the program to do a lot. So that's in 9 minutes already. That describes some of the potential things that we can do. Let's go on here and do something else. I'm going to browse. I'm unloaded that PDF and let's so here is a set of layout drawings. So it can browse through those too. Part drawings. anything that you need. Okay. Anyway, 10 minutes and over. Thanks for taking the time to look at this. And I'll make another video here showing what it can do with layout drawings. And then the next thing is that we're going to have it, review structural engineer and architectural drawings, and it will be able to show you. It's going to be a different application, but artificial intelligence can look through our architectural drawings and a set of structural drawings before you even start the project, and it'll tell you how many RFI are going to be needed and let you know how much missing information there will be in a set of structural architectural drawings. And boy, that's helpful. All sorts of things that this can do. Thanks.